Well, good morning, dear, and welcome back. You have started watching videos on introduction to machine learning, but I just came from outside, and you can see that I am wearing a mask. And as you all know, this is the second wave of COVID-19 infection around the world. Okay. And situation is very grim for our country, especially as we can see some 300,000 infection per day. So be careful, and whenever you go outside, wear a mask. Now I can put it down and actually concentrate on our today's lecture. So today we are going to discuss a very interesting topic, that is convolutional neural network, which is different than fully connected neural network. And of course, the convolutional neural network as a whole also holds the hand of the fully connected neural network. So it's very exciting, and in image processing, it has proved to be a very sophisticated tool and solving many problems in healthcare and in autonomous car, okay, in dynamically recognizing image. Wherever image recognition is there, CNN is the first choice, So today we are going to discuss the, of course, only fundamental, the inherent details, some details about how it works, with a very fun example, not typical though, that pizza recognition by my robot. So, as you know, I am a little bit obsessed with robot because working so many years in this area. So I envision that one day we will be able to give order just image of the pizza, and robot will be able to recognize it. And once it is recognizing, it will plan how to prepare it, and then it will manipulate many other furnace and many other detail. And in a fully automated way, it can even it can know from artificial intelligence that each pizza, how many minutes in the furnace it required to be put on, all kind of details, right? And um, it will also pack the pizza and deliver it through a drone, which is another robot. So this is, and in doing that, we can save many people from working in a very hazardous environment, and we can utilize their talent in some other more useful way in other areas. Although this is a very fun example because pizza recognition is comparatively very easy, because image processing with similar images turns out to be uh, easier, okay, than heterogeneous. But we will take this example because our main objective is to introduce you how convolutional neural network works. So for recognizing pizza, what my robot first need? It needs huge data. Okay, data here is different kinds of pizza, and which is I think the data is easily available, but it has to be labeled data. Say here I have shown 5 different classes tandoori pizza, so you should have at least 100 200 images of tandoori pizza being prepared in so many different sauce, not same image, okay, but same class. Similarly, cheeseburger pizza, okay, 200, some 200, 300 images. Pepperoni pizza, so margarita pizza, vegetarian pizza. This so tandoori vegetarian pizza. These are very common in our country. Okay, so it's fun, right? So you have show our basic raw material with which CNN will be trained are labeled data, and that sometimes through challenges in many other applications. No, um, you know, it has application in, for example, detection of various types of tumor, cancerous tumor. In that case, you need use because the recognition mm, precision uh, is an issue in many applications, right? So we need to train a CNN, because it is supervised learning again, we need labeled data. So once we have those data, my robot need to learn. Okay. So how? See, you have input neurons. Actually, this can be a image, raw image, directly after removing noise and all. You are inputting it. Okay. And image for computer, as you know earlier we have discussed, is actually a matrix with pixel intensity values. If it is grayscale, one matrix. If it is colored image, three stacked matrix. So parallelly, computer can read those those and store those information, right? So the job of my robot is to extract information and get trained itself before recognition can take place, right? So there you see, this is hidden layer. Unlike fully connected layer, here a neuron is connected to a patch. This is also known as filter. It has several names, right? Sometimes it is called as patch, or it is filter, kernel, same thing, right? So basically, this is, suppose robot has a torch, and these are on the, and it is inside a dark room where all on the wall all the informations are there, but it need to explore by searching with the help of the torch. Okay, so how it will do? It will just from one side, it will go, say, in a particular wall, say where red color informations are there. So it will go there, it will, for a color image, it will go there, and then it will search and convolution, it will do the convolution operation, then come back and search, and then like that it will explore the entire wall. Okay. And main idea is how to extract information, because in case of fully connected layer, we inputted the features, right? So here, by hand coding, by our experience, by our knowledge, okay, sometimes wisdom, okay. So now we are not doing that. We are cleverly doing the network to extract the feature, right? So its main idea of convolution network is to extract information which is there, already there in the input image, and get trained. Train means, as usual, know about the parameters, so fix the parameter during training, and use those parameters when actual recognition need to be done. Right. So convolution operation is, you see, this is a, says 3x3 convolution, and this is input image, and it is creating a feature map in a reduced dimension. How? Just it is a filter, and it is see, from starting from here and just multiplying is making a dot product. Okay, and we will show it. It's very simple, and then added them together and putting it here. So it is a, it's called feature map. Okay, so just like torch, it is creating and putting that information in a which is called feature map. So these are the fundamental steps. You know, first you need to make the convolution operation, that is apply filter to generate feature maps. Okay, and in TensorFlow, of course, you can write this just statement and it will be done for you. But you need to know what is going on. Then at non-linearity, which is normally ReLU, rectified linear unit, as we have discussed, okay, because it gives you wide range for training your parameter. Then you downsample and reduce dimensionality, and so that your spatial variance could be protected. Okay, that is done by pooling. So these are the three fundamental operations which are done. Okay, and we will to create a feature before it goes to training a fully connected neural network. So here is my, so training operation. Suppose training operation is going on, and I have a number of tandoori pizza. I am now training my network that this is tandoori pizza. This is tandoori pizza. This is with the various variants of tandoori pizza, and I am trying to get all these parameters fixed during learning process. So learning process, again, as usual, you need to run backpropagation algorithm, and only difference is here in convolution layer, the neurons are not fully connected, right? So this computation is done locally, okay, and also the basic strength of CNN is that computation, although huge, can be done parallelly, okay. So for example, when you are convoluting in red image, then simultaneously blue and green can be done, right? So these are the operations. So use some kernel. Kernel means say 3 cross 3, 5 cross 5. Normally they are odd filters with odd number. Why we will discuss in deep learning. So this, is an image, and then convolution operation is done, and then it is for capturing nonlinearity. You are feeding it to a activation function value, and then you are getting a another convolution layer. You are getting a feature map, okay. And after activation, then again say you are applying pooling, that is reducing some parameter. Then again because again and again, depending on your problem, you need to apply this convolutional activation pooling, convolutional activation pooling, right? So more in the hierarchy you go, more number, higher quality, of course, feature you get. Say you are here 32 features, you got feature map, then 64, 128, like that. You can increase the number of features, because more finer training you want, more features are required. And then of course flatten them means to make the as you know, say you have x1, x2, as I told. So this is our huge dimension n cross 1. So flattening means you do like this. So it's a vector now. It's a vector which is being fed as an input to a fully connected neural network, so that it will run backpropagation algorithm and fix its parameters during training. So this is exactly same as what you have done in the earlier class, okay. And then during training, I am telling you, if this kind of thing is there, then it will be so the output will be some vector value will go to a softmax function, which will calculate the probability, okay. So if tandoori is there, probability will be calculated 0.8 is maximum probability, right? So again and again with different class, each class having several images, you need to train fast, okay. So this is convolution operation. So during training, convolution operation has to be done. And say I have a typical kernel or a filter 3 cross 3, and I have an image here, okay. So this is just illustrative example, small. So this multiplied by this, plus this multiplied by this, plus this multiplied by this, 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 and add all of them, right? And if you see, you will get output 7, okay. So same image, same filter, you get only one number, okay. So this is the way actually convolution operation is done, okay. So you see, this is well-known Lena's image. So you have this input image, and you have a kernel or filter whose elements are like this, okay. So then again, as I told you earlier, so this is what after convolution, 3x3 convolution, you will get this feature map. This is called feature map, and in that feature map it will look like this, because it is important to understand that we are trying not to get the appropriate image, but the features. What, for example, what is the nose, what is the eye of Lena, like that, okay. Total number of filters, generally it could be varying from 32 to 512, depending on your design, depending on your problem. Okay. For example, what computation will be done for a 3 cross 3 filter in the hidden layer? How, say the neuron n neuron. That means you have a neuron having m input, and this neuron is in the hidden layer, right? Having n number of output. This is the meaning of that. So you have selected one neuron, okay, and what it is computing when it is doing convolution. This is what it is computing, okay. So, so you see, now all these are your parameters. W13, W22, W23, 21, sorry, 21, 22, W23, like that. Okay, you understand. 31, 32, 33. So this is what they make it curly so that I can accommodate the bias also. So, so this, as you can see, so this is getting 1, 2, 3, 4, 5 because it's a 5 cross 5 filter plus bias now has to be actually fade for activation. Okay, so activation is ReLU activation, and then you will get the output for the next layer. So that's how. Okay, so these are the parameters which are needed to be learned. Okay, so you see, convolution layer actually has, you see, another, say this is my input image, this is my input image, okay, and here is some, I have added some one row, one column with all zero. Why is it fun? This shows you example of a convolution operation. Okay, so we have 7 cross 7 into 3 RGB image, for example, and this is your input image. So this color is one input image. This is your filter, 3 cross 3 filter, right? So you are so each filter is having parameter attached to it, parameter in the sense in vector form. Okay, 3 cross 3 means 9 parameter will be there. So they are to be learned. Okay, for each dimension, 9 parameter, 9 parameter, 9 parameter. So in parallel, they will get training. That means they will explore what is the information there. Now, the adding 0 is called padding, right? Why do we add 0? Because you see the way the torch is moving, one stride means at one go, one column is being shifted, right? Two stride means two column at go, it is shifted. The basic idea is to capture the information in a reduced dimension, right? Important information as a feature map, okay? Now, in doing so, if the important informations are there at the corners, you see, and if you start from here without padding, then this corner will be visited minimum number of times, whereas whoever is in the middle will be visited many times, will be explored from various corners, for example, right? To avoid that, so that corner also gets weightage, we sometimes apply the padding called zero padding, right? And it gives my also output vector same dimension as input vector if sometimes that is needed. So that's what we do. So here there are two filters, W0, W1 parameters attached to those filters. This vector, okay, W0 is a vector, W1 is a vector, okay. So the single element in the output volume is sum of all the convolutions across the bias, as you can see. So this is parameter, and you are getting, this is output from this filter, okay, output from this filter, okay. So this is my robots bearing the torch means, okay. So this is two stride. You can see that it missed at one go. It start from here, and then second time it started from here. Okay, stride equals to 2. So this is called stride. Okay, so if you are confident that there are a lot of redundancy in the input image, and you do not want that, so you can make stride higher. It will save your computation, of course. Now this is about convolution operation. Now non-linearity, right? Now we pass the result of convolution operation through some activation function, and there are many activation function. I have discussed in my earlier class that why sigmoid is not a good choice when you have large data, okay, for training. So for small neural net is fine, having few hundred neurons it may be okay, but not when you have millions of or several hundred thousands of parameters, right? It's not a good idea. Good idea is ReLU. So ReLU, rectified linear. You can, I think you should not be worried that that is telling rectified linear unit and it is nonlinear. It is capturing nonlinearity. Yes, it's a nonlinear function, right? Because you see, if the Wi xi plus bias, if you are calculating, right? So I equals to 1 to say 5 or whatever it is. So, and when this is equals to negative, any negative value, it will be this ReLU activation function output will be 0. It will not allow this weight training when it will be negative, right? So on the other hand, if it is positive, it will just output the same value. Okay, so that is the meaning of ReLU function, because this is 45-degree angle making. So when x is negative, it is 0. X is positive, it is giving you the same value, where so there is no no chance of vanishing gradient. But you can raise a little issue, right, sir? You are just eliminating everything. Who knows that there might be some negative compensation which may lead to healthy training. Yes, so that's why sometimes leaky ReLU, to accommodate little bit negative values, leaky ReLU with this function. So this is all because it's a very dynamic field. Everybody is trying to have, depending on their specific problem, come out with a new kind of activation, new kind of model, all kind of thing, right? And this is your another ELU activation function, exponential linear unit with this definition. So all kind of things there, but this is very, very common. Okay. So stride and padding, I discussed that when to increase stride. If what is the meaning of stride, you know, right? And what is when to increase and how to fix that stride. If you want to, in my robot wants minutely to capture all the information, then better to keep stride 1. Okay, and if you know the image is having a lot of redundancy like these are, right, it looks similar to all of them, so you can increase the stride 2, right? So this is your stride, and this is your see, with padding. Okay, it is, you can just see it is ensuring that this corner are being visited, you see, so twice it visited this one. So you more add another layer, so thrice it will be visited, so that you do not lose any information which might be here. Okay, so there is a very important thing is size. Okay, with you see, after convolution with filter size f together with padding p and stride s, the size of the feature map, okay, will be, width of the feature map will be w minus a plus 2p divided by s plus 1. These are all very empirical, very simple. You can see by doing that these are the fact. Width, height will be h minus a plus 2p divided by s plus 1, same. Okay, and number of channels, number of filters applied will be number of channels. So we illustrate more on padding. Say 32 cross 32 cross 3 is the input volume, and if we imagine two borders of zeros around the volume, it gives you this, right? Then apply convolution layer, say 5 cross 5 cross 3, filter and stride 1, then you will again regain. This is a possibility. So by judiciously selecting, if you want that input image size and output after convolution, the dimension should be same because it might help in some computation, then judiciously this filter size can be selected. You can add padding, and that will ensure that yes, output and input dimension will be same. So that is another advantage of this padding. Now, important operation, third operation in convolutional neural network is pooling, right? So it basically reduces the amount of parameters and computations in the network, controlling overfitting by progressively reducing the spatial size of the network. So this is very, very important. And how it does is very simple. Say I am using max pooling operation. Okay, so using 2 cross 2 filter size, max pooling filter, right? So here I will just torch, okay, 2 cross 2, whoever is maximum value, I am capturing it. Here it is 6. Then I am sliding it here, 2 cross 2 filter. Then what is the maximum value? 8. So I am reducing and I am putting it 8. I am forgetting 4 cross 4. Now it is a number like that. Here 3, here 4, like that. So this is max pooling operation. Extremely simple, right? Then you can also decide average pooling. So all depends on actually your main objective is through convolutional neural network how to capture information which is there in the input image, raw input image. So these are all the part of the algorithm. You are trying to, as far as possible, as minutely as possible, you are trying to capture the information. That is a feature. For that, whatever needed to be done, you can do. Average pooling also possible. That means you are not neglecting anybody. Okay, it's more democratic. So 1 plus 1 plus 5 plus 6 divided by 4 will be the value. If you just you can calculate 2 plus 4, 7 plus 7 plus 8 divided by 4. Okay, so this is average pooling. You can devise your own. Okay, and you can, if you can prove that in a particular data set it is working better, and we'll study your method also. Okay, definitely I encourage you to do that. Now I am showing you a particular with an example, very famous example. Say I am my CNN is trained with all kinds of cars, truck, aeroplane, ships, and horse, and then after training is over, all the automobile, aeroplane, like that. Okay, huge data. I have millions of data, level data I had, and I have trained. Okay, different kind of car. Okay, 100,000 different type of car, and I have trained parameter. I have aeroplane, different types, I train the parameter. Now I am deploying it for recognition. So when the car will come, so again it will just take the image and convolution value, and pulling. So all this, through all this operation, it already knows the parameter, right? When the car is coming, no more training. Just it will use those parameters and output that this is a car. Okay, so already trained, and then it will try to recognize that this is car, not a truck. Okay. So it has two component, hidden layer or feature extraction part. During training, it tries to extract the feature, and classification part. The fully connected layer will now serve as a classifier. Okay, and they will assign a probability value, because the classifier also contains submax function. And then hyperparameter and design choices, you see, is a design. So you have, during training, you have to have make a decision that what will be my filter size, even at what level, what filter size. I can also vary filter size. For example, in first convolutional layer, I will use 3 cross 3 filter, because or 5 cross 5, because I do not want to see minutely. I will just make a all the information I will allow to pass. Then 3 cross 3, I will minutely see in second layer, right? All kind of decision is yours. Then stride, padding, filter count, how many filters, these are all to be done. And then choices of activation function, number of CNN layers are very important design aspects, and that affects the performance. Here you can see, I will just give you a typical number of parameters in CNN model. Say input size is a grayscale image 20 cross 28 plus 1. So there is input image, there is no parameter. Convolution, 2D convolution operation is happening with a 5 cross 5 filter. So this is the size, and then parameter will be 5 cross 5 cross 1 plus 1 for bias times 32, because of 32 feature you, okay. So number of filter, each filter is this, so parameter is 832. Then max pooling, that means you are reducing the size. Is there any parameter here? No, there was no. If you just see your pooling operation, you do not need to attach any parameter for learning this. You are just simply, once you have this, simply you are calculating. So there is no parameter attached. That's why 0 parameter. So then again, second layer of convolution. Okay. So this is again 9000. Then max pooling operation you are doing, no parameter. Then in the dense layer, see, now this is the fully connected neural network again, right? These are the feature map which you have inputted. Now it requires training, right? And it has the lion's share of the parameters again. So again, please utilize rainbow activation function, which will allow you to actually run your algorithm quite a long time, several hours maybe, right, for training. And then output also has size this, say 10 outputs. 10 outputs are there. So total parameters in a typical CNN, which has this kind of size, which is input layer, 2 convolution layer, 2 max pooling layer, 1 dense layer, and 1 output layer with this size, okay, having this many parameters. So how many data you require, you can easily imagine. At least maybe 1 million level data you require to train. Okay, so huge data. So I suggest, I wanted to tell you that how CNN works, okay, how to train it, okay, and training again is very, very efficient, because parallelly in this convolutional part, because you are computing locally, and you see the number of parameters are not that many compared to what you have in the dense layer. So you can today, so it require computation, it require data. So what are the basic raw materials? You know, huge data. Today you have image, this MNAST, QMNAST, all kind of open source forum. So you can take data. Then you have tremendous computation power. Earlier we used to run, you see, in 1995 I published one paper on neural net applications having few parameters, and we could run in the powerful personal computer. But this type of thing you cannot run, right? But you have a great facility. If you have a laptop, you have Gmail account, then Google Colab. Colab is what? It is giving you storage, enough storage. It is giving you processing power, enough processing power in the cloud, which you cannot see. Only thing, you have to create a model, you run using their resources, and learn how neural network is actually, convolutional neural network is performing. And then all kind of things which you have, confusion matrix generation, number of parameters, how many parameters are there, what is the performance, confusion matrix you can generate. You have learned everything in machine learning. So you can do the experiments. Today it is possible, even in the COVID situation, right? So you can, at home, while you are at home, you can access those facility and learn. And that's it. So I wanted to convey these things to you. That is the convolutional neural network, which is not fully connected neural network. It has convolutional part for extracting feature. It has fully connected neural network part. So you can easily tell that fully, can I replace fully connected neural network with other, because it is doing classification, right, with other tools which you have learned. For example, support vector machine, answer maybe yes or no depending on the problem. Many people have tried, okay, because support vector machine as a classifier is better than a fully connected neural network. But since they have homogeneous kind of thing, same backpropagation you are running, the same way it is trained, right? So homogeneous training is there, so it is better to use neural network. And so have fun, and these are some of the references, okay? So and I wanted to, this is what I wanted to convey. And again, I'm telling now, I'm leaving you. Stay safe, have a nice day, bye bye.